Steroid and therapeutically related compounds. Objectives: to able to understand the biosynthesis of steroid hormones from cholesterol, to be able to determine the 5 general groups of steroid hormones, and to know the differences in actions and the various therapeutic uses for these compounds. What is steroid? Steroid acts as a hormone and are crucial substances for the proper function of the body. Steroid hormones and therapeutically related compounds. Steroid hormones and related products represent one of the most widely used classes of therapeutic agents. These drugs are used primarily in birth control, hormone replacement therapy, inflammatory conditions, and cancer treatment.
Steroids can be divided into 5 groups by the receptor to which they bind. These are estrogen, progestin, androgen, glucocorticoids, and mineralocorticoids. Vitamin D derivatives are 6 closely related hormone systems with homologous receptor.
Cyclopentanoperhydrophenanthrin nucleus. Steroids are modified triterpenes which derived also from squalene by cyclization, unsaturation, and substitution. The nucleus of all steroids is the tetracyclic C17 hydrocarbon 1,2-cyclopentanoperhydrophenanthrin substituted by methyl groups at C10 and C13 as well as an alkyl side chain at C17. The modifications include a tap at the 11, 16, 17, 18, 19, 20, and 21 positions, conversion of the 3-hydroxyl to a ketone, and isomerization of the 5,6 double bond to the 4,5 position. A number of additional modifications, not shown here, occur during conversion of the steroid hormones to inactive metabolites. Sites of unsaturation, such as double bonds, are often referred to using the Greek letter D. Thus, steroids containing the 5,6 double bond, such as cholesterol, are designated D5 steroids. Those with the 4,5 double bond are called D4 steroids.
Cortisol is a 21-carbon steroid. Conversion of the 11-beta-hydroxyl to a ketone yields a cortisone, an inactive metabolite of cortisol. Steroid that lacks the 17-alpha-hydroxyl corticosterone has 70% lower glucocorticoid activity in humans, although it is a major glucocorticoid in rats. Glucocorticoid activity requires 11-beta-hydroxyl group and alpha-hydroxyl group linked to carbon 17.
In the additional unsaturation of ring A, it enhanced the glucocorticoid or mineralocorticoid potency ratio, and also it metabolized more slowly than the hydrocortisone. Changing single bond between carbon 1 and carbon 2 into the double, the anti-inflammatory effect enhances salt and water effect. Testosterone lacks 2 carbon side chain attached to the 17th position, making it a 19-carbon steroid. These hormones play profound roles in reproduction, in the menstrual cycle, and in giving women and men their characteristic physical differences.
The most potent, naturally occurring estrogen in the human body is 17-estradiol, followed by estrone and estriol. Estradiol is not effective orally due to rapid metabolism in the liver, but the placement of ethinyl group at carbon 17 increases the resistance to metabolic inactivation and makes the compound orally effective. The presence of its aromatic ring gives high affinity binding to receptors, but the alkylation of this aromatic ring can decrease its activity. On the other hand, altering its steroidal structure does not show an essential effect on its activity. Some of the therapeutic uses of estrogens include birth control, hormone replacement therapy, and treatment of estrogen deficiency from ovarian failure or after oophorectomy. Estrogens can also be used in the treatment of advanced, inoperable breast and prostate cancer in men and postmenopausal for women. Next, we have progesterone. For the structural activity relationship, its steroidal nucleus is essential for activity. Removal of the methyl group at carbon 19 and unsaturation of ring B or C can increase the activity of progesterone.
Androgens. Anabolic steroids, technically known as anabolic androgenic steroids, are drugs that are structurally related to the cyclic steroid ring system and have similar effects to testosterone in the body. In men, testosterone is the principal secreted androgen. These endogenous compounds have two important activities: androgenic activity for promoting male sex characteristics and anabolic activity for muscle building. The alpha group at C17 position favors androgenic activity. The oxidation reduces androgenic activity while esterification favors anabolic activity. Alpha alkylation favors anabolic activity at C17 position. At C7 position, the attachment of alpha alkylation favors anabolic activity, while the keto group at C3 position enhances androgenic activity. Junction of A ring with a pyrazole ring or introduction of an oxygen atom favors anabolic activity. Alkylation favors anabolic activity at C1 and C2 position. The removal of C19 favors anabolic activity and reduces androgenic activity. Lastly, the double bond at C4 and C5 is reduction with or attachment of chlorine or hydroxyl group. Known modifications of testosterone molecule include alkylation at the 17th position and or modification of the ring structure. The goal of these modifications is the production of derivatives that are more anabolic and less androgenic than the parent molecule. The esterification of the 17-hydroxyl group by carboxylic acids also increases the steroid activity due to the prolongation of the action, as the steroid gets lipophilic properties and the capability of retaining in fat tissue.